So the video you're going to watch today, section 9.3 on ellipses, is one that I did do last year, kind of in week 5 or something like that, when we were doing distance learning. But it's a good lesson, so I decided that I was just going to have you watch this video today. So if you hear some references from 2020, that's kind of why. When you get to the end of the video, you'll see me again because I'll come back and talk to you a little bit more. So our central question for today is, how does the equation of an ellipse relate to the features of its graph? And then what we want to be able to do is describe the features of an ellipse given a graph of an equation. So first and foremost, I'll give you a little bit of a definition of what an ellipse is. I would suggest pausing the video at this point if you want to copy this down. I'll try to present, I'll get the notes in there as well. So that's really up to you at this point. But an ellipse is a set of all points in a plane such that their sum of the distance from 2 points, the foci. You have this kind of circular thing that kind of looks like a track. So a foci, and we've talked about the focus before, the focus is inside of your ellipse. It's in this drawing, it's F1 and F2. Those are your 2 foci. And it's created by just kind of essentially putting a string together and kind of walking it around and doing that type of thing. But anyway, so it's made up of 2 parts. It's made up of a major axis and a minor axis. The major axis of an ellipse is the longer of the 2 pieces of it. That major axis, the end of that major axis are our vertices, or the vertex of our graph. The distance from the center to the vertex, we call that A, in either direction. So that A is going to come important when we start talking about the formula for an ellipse. So the distance from the center to the vertex, we call that A. So the whole distance of the major axis is 2 times A. The minor axis is the shorter of the 2, and it makes up its co-vertices. And the distance from the co-vertices to the center, we label that as B. The center is obviously what we would call the midpoint of the majors and minor axes. And there's also a third part in there that's not there, but we're going to talk about quite a bit, and that's the distance from F1 to the center, or from the focus to the center. And that we're going to call C, and we're going to have a formula for that here in just a little bit. So there are essentially 2 types of ellipses, what I call short and fat, and tall and skinny. In a short and fat ellipse, the major axis is going to be along the x-axis. It's your longer of the 2. So you're going to have kind of this short and fat thing, where your minor axes are up and down. The other type is this tall and skinny. In a tall and skinny one, your major axis is going to be kind of that vertical piece. So now your vertex is along that kind of that y axis. So those are the 2 types, short and fat, tall and skinny. We use those then to help us put them in as an equation. So there are, again, 2 equations for this. The first one is x minus h squared over a squared plus y minus k squared over b squared equals 1. And this is if your major axis is horizontal. And how do we tell if it's horizontal or not is you really look at those a and b values, or that a squared and b squared value. If the a squared is underneath the x, or if the larger one is underneath the x, then it's going to be that short and fat one, or a horizontal one. Now, keep in mind that h and k are the center, just like they were in a circle. It's the center. And really the only difference between this and a circle is 1, it has to equal 1, and you're going to have something divided by underneath there. The other one we could have is the x minus h squared over b squared plus y minus k squared over a squared equals 1. Now in this case, you'll notice the a squared is underneath the y value. And if it's underneath the y value, then this is going to be more of a vertical. It's going to be that tall and skinny type of graph. So the next thing we're going to look at is we're going to look at a little bit of Desmos. Okay, so just a quick little Desmos thing on video on this. So we've got our ellipse. Yeah, so here's our equation for an ellipse. And yeah, I know it looks like a circle, but if you think about it, if the a and the b values are 1, you've just got a circle. So as I move this a value, as this a value gets bigger and bigger and bigger, and the a value is bigger than the b value, and that's really what you have to keep in mind about this stuff. You don't get over concentrated on what's the a value, which is a and which is b. It's which direction it goes. So if the a value is underneath the x value and that a value is bigger, obviously we're going to have, I kind of call this a short and fat ellipse. And again, remember this a value is the distance from here to here along this major axis, and the major axis is always the one that's longer. So in this case, this is my major axis. If I take and move this back to 1, and now I move that b value, okay, now I call this kind of the tall and skinny type of ellipse. And now this distance right here is along my major axes, and this is the major axes. So where the A is and where the B is really kind of irrelevant, so to say. What you have to keep in mind is that which direction it's going. If you've got a short, if you've got a tall and skinny one, your B value, your bigger value is going to be underneath your Y.
Okay.
If you have a short and fat one, the bigger of your two values is going to be underneath the X value. Okay, so there's kind of that. We can move this around, of course. You know, this vertex can slide all over the place, and you've got different types of ellipses that you can make as you're doing this. So just kind of keep these things in mind as you're talking about ellipses and what these different equations can look like.
Okay, so let's take a look at an example. We're going to graph this equation, x squared over 45 plus y squared over 36 equals 1, and we're going to come up with the coordinates for the foci.
All right, so in our first example, we're going to graph the ellipse with that equation, and we're going to find the coordinates of the foci. So the first thing we're going to find is we're going to find the vertex. Now the vertex is, there's nothing being subtracted, so our vertex is just 0, 0. The next thing we need to find is we need to find our a values, because when we're looking at graphing this, if we look at the graph of this, our center is right there, and we want to figure out, one, what direction this goes, and then we want to figure out how we can go about finding that focus. So we've got that vertex is at 0, 0. So the way we can figure out what it goes is this way, is we know that this is going to be our a value, and this is going to be an a value as well. So if we can find that a value, we've got one of them, and I think that's going to go a little further this time. And then our up and down is going to be our b value. Okay, so this value here is going to be kind of a b value, and this is going to be a b value here. Now, how do I know if this is going to be short and fat or tall and skinny? Well, we look at these values right here. Since 45 is bigger than 36, that tells me that this is going to be the long, and this is going to be kind of this short and fat type of graph. So what we want to be able to do is we want to be able to find, kind of this point here, those 4 points. So that's the distance of a. So by our formula, we know that a squared has to be 45. So this is the a value. So we take the square root of 45, and the square root of 45 is 3 radical 5, which is just over 6. So this here is going to be the point 3 radical 5, 0. And that point right there is going to be negative 3 radical 5, 0. So we've got those points. Now we want to find that point right there. Well, we know that b squared is equal to 36. So b is equal to 6, and it's plus or minus 6. So then this is the point 0, 6, and this is the point 0, negative 6. So the graph of our parabola is going to look something like this. Okay, and there are the coordinates for each of those points. Our major axis is highlighted in yellow. Our minor axis is going to be highlighted in blue. Again, difference between our major and minor. Major axis is longer, minor axis is shorter. So the next thing we have to find then, according to our directions, is we need to find the coordinates of the focus. Well, the focus is going to be a point on the major axis, make it pink, right here and right here. Now, this distance right here and this distance right here, those are going to be the same, and we're going to call that the C distance, and we talked about that in a previous slide, but here's what happens. When we're trying to find that focus, and the way we find the focus, or the foci, is we're going to use the formula that C squared is equal to A squared minus B squared. So kind of the Pythagorean theorem, but not really. So this is the formula we're going to use to find that C value. So in our form problem here then, C squared, A squared was 45, B squared was 36. So our C squared is going to equal 9. So that now what we have to do then is we obviously have to take the square root. So C is equal to 3. Well, it's going to be plus or minus 3. So we know the distance from the center to this point has to be plus 3, and from there to there has to be minus 3. So our foci points, we're going to take our vertex, so we're going to name that point right there. Well, that's the point 3, 0. And we need to name that point right there, which is the point -3, 0. And there's your solution for that problem.
Okay, so now let's take a look at question number 2. Now with this one, what I'm going to ask you to do is I'm going to ask you to pause the video at this point and take out a sheet of paper and see if you can do what's asked of this question. When you think you're good to go, press the play button and yeah. So the answer, there it is. Okay. And again, if you want to take a little bit longer, just kind of pause the video and we'll keep on going forward here. So now the next example that we give, we are going to look at what the center is not going to be at the vertices, and we're going to find several different things.
All right, so in this next example we're going to identify the center, vertices, co-vertices, and foci, but in this case, now our center is not going to be at 0, 0, 0 any longer, but it really shouldn't add too much of an issue for us. So start out with finding the center, make sure it's the opposite. So the center is going to be at -3, 1. And I would suggest at this point kind of starting to go ahead and graph this. So -3, 1, we'll overemphasize it a little bit. Let's say that it's right there. So if we look at our A values and our B values, it looks like our A squared is bigger. So our A squared is going to be 16. Square root of 16 is 4, so that means our A value is 4. Our B squared is 4, so our B value is going to be 2. And remember, these are both plus or minuses. So we're going to have the short and fat version of this. So my A value is changing by 4. So we're going to go 4 in this direction, and we're going to go 4 in that direction. And that'll give us our vertices. So our vertices are going to be at -3 plus 1. -3 plus 4 is 1. So we've got 1, 1 is our vertice. And then -4, so -7, 1. So there's our vertices. Our co-vertices are going to be our B value. So our Y value is changing by 2. So 2 and 2, somewhere right in there. So our co-vertices, my Y value is what's changing now from my center. So my X value is going to stay the same. So -3, it's going 2, so -3, 3. And then the other one's going to be -3, -1. So here's our ellipse right here. And we've got our coordinates for our vertices, our co-vertices. We've got our center. Now the last thing that we have to find is the foci. So remember the foci, the way we find the foci is C squared is equal to A squared minus B squared. So C squared is equal to 16 minus 4. So c is the square root, c is then going to be the square root of 12, which then that is going to be plus or minus 2 radical 3. And we'll just leave it like that. So our foci then, since this is on my x, since my major axis is along the x, my x value is going to change. So our focus is going to be about here and here. And it's going to change from the center. So we're going to go negative 3 plus 2 radical 3, 1, and negative 3 minus 2 radical 3, 1. And there's my foci.
Okay, so there's the first one. Now the second one, same thing. Hit pause right now. See if you can do that one. And I'll put the answer up here in just a second. Okay, now the next one that we are going to look at now, we're going to work on kind of that completing the square piece of it, where now we have the equation of this eclipse. Now it's in that standard form. And we're going to graph this eclipse and we're going to find kind of those key features as well. So the formula that we're using is there. Work through that one with you and we'll...
All right, next example now. Now we're going with the uh-oh. Now we have the equation, we need to graph this. So we need to get this into the form of our standard form. Again, our standard form for this, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And that's kind of the key here in this one, is that this time they have to equal 1. And so it's going to change a little bit how we do it. Really, a lot like we did before. We're completing the square. So we're going to take this and we're going to go ahead and complete the square for it. So that means we're going to kind of box our x's together. So we've got 2x squared minus 12x, and we're going to put our y's together, plus y squared minus 2y, and I'm going to put the negative 15 on the other side. I'm going to put the 15 on the other side. Okay, so we need to complete this square. So the first thing I'm going to do is I'm going to factor the 2 out. That's going to leave me with x squared minus 6x. Now we've got to add in our box. We're going to close that off. We'll fill the box in just a second. So plus, don't have to factor anything out of the y squared. So y squared minus 2y plus our box. That's going to be negative 15. Oops, I don't know why I put a box there. That's going to be negative 15. And then plus our 2 boxes. Ran out of room. So I got to figure out what we got to put inside the boxes. So half of 6 is 3, so we're going to put a 9 there. So if I put a 9 there, I've got to put what over here? I have to put an 18 here because we factored the 2 out. 2 times 9 is 18, so I got to put an 18 over there. So this then factors into 2 times x minus 3 squared. Plus, now we got to factor this one. So half of 2 is 1. 1 squared is 1. So we got to put a 1 in that box. So this becomes y minus 1 squared. Now that's going to equal negative 15, so that's, I think, 4. But it has to equal 1. So we've got to get this to be 1. So, well, how do I get this to be 1? I'm simply going to take this, and I'm going to divide every single piece by 4. So when I divide this by 4 and I reduce, the 2 and it goes away, so this is just left with x, let's try to make this a little bit nicer, x minus 3 squared over 2 plus, this doesn't change, y minus 1 squared over 4 is equal to 1. Okay, so now we have pieces that we need. I'm going to make this a little bit smaller. So a couple things that you need to take note of. One, the values out there can't be anything here. This has to be right here. This always has to be a 1, so there can't be anything there, and the same thing with the y value, so that's good. Okay, we've got everything else that we need. We've got it equal to 1, so we're all good there. But notice where my value is a little bit higher. So I've got this 4 over here. So that's going to create my a value and b value. So represent the ellipse, graph the ellipse. So we're just going to graph it real quick. To do that, I need the center. The center is at 3, 1. So there's my center. My a value, or my a squared value, is going to be 4. My b squared value is going to be 2. So my a is equal to plus or minus 2. And my b value is equal to plus or minus the square root of 2. So my center is at 3, 1. I think we've had that quite a bit. That center is at 3, 1. Now we got to figure out which way is this going. Is it tall and skinny or short and fat? Well, it's going to be tall and skinny because of where that 4 is at. The 4 is underneath the y. So that's going to go up 2 and down 2. And it's going to go the square root of 2 this way and the square root of 2 this way. And it's going to look something like that. Now you could find the focus. You could find those points just like we did before. If you're asked in your quizzes or anything to find those points, you know how to find those points now. You know how to find your c value as well.
Okay, so then kind of like we've done here all along now, I'm going to put one more example up there. I'm going to have you go through this example, press pause, and then when you're done, come back and look at the solution. And so there's the solution. And you'll notice in this one I did find the center, the vertices, the co-vertices, and the foci as well, which you should be able to do. So there takes care of...
I'm back. Obviously, you're not going to do the assignment that I may have talked about somewhere in there. I don't remember, but your assignment's going to be on page 487. It'll be down below. 16 through 20, 22, 23, 25, 26, and 27. Hope you enjoyed the video. I will see the Packer group on Thursday. Have a great week, everybody. Rest of the week.